Did you know the moon's not perfectly round but rather shaped like a lemon? That's right. Our beloved lunar companion doesn't sport a perfect sphere but rather bears a resemblance to a citrus fruit. Its shape is due to flattened poles and a bulging equator, much like the profile of a lemon. While it's a far cry from the perfect circles we drew in our elementary school art classes, this unique shape adds to the fascination of our celestial neighbor. Now, just when you thought space couldn't get any more surprising, let's take a journey to the center of the Milky Way. Greetings, fellow cosmic explorers. Welcome to Cosmic Science Fiction, the channel where we embark on mind-bending journeys through the vast realms of the unknown. I'm your host to the mysteries of the cosmos. If you've been enjoying the cosmic wonders we've been uncovering together, don't forget to hit that like button. It's like fuel for our spaceship, propelling us further into the depths of science fiction's uncharted territories. And of course, if you haven't already, be sure to subscribe to Cosmic Science Fiction. Hit that subscribe button and join our crew on this interstellar adventure. By subscribing, you're ensuring that you never miss out on the mind-boggling content we have in store for you. What do we find there? A colossal cloud that contains a compound called ethyl formate. Now you might be wondering what's so special about ethyl formate? Well, it just so happens to be the very thing that gives raspberries their delightful flavor, and it carries the sweet scent of rum. Yes, you heard it right. The center of our galaxy smells like a raspberry-flavored cocktail. Imagine for a moment floating in this interstellar cloud, surrounded by the aroma of raspberries and rum. It's a far cry from the sterile, metallic smell we often associate with space travel. This discovery brings a whole new meaning to the term cosmic cocktail, doesn't it? So there you have it. Our universe is a place of endless wonder and unexpected delights. From a lemon-shaped moon to a galaxy that smells like a fruity cocktail, there's so much more to space than meets the eye. So next time you look at the moon, remember, it's a lemon, and somewhere out there space smells like a fruity cocktail. Ever felt like a day just drags on? Try living on Mercury, where a day lasts 59 Earth days. No, really, the smallest planet in our solar system, Mercury, has a very peculiar sense of time. A single day there lasts the equivalent of almost 2 Earth months. Imagine waiting that long for lunchtime. But it gets even weirder. A year on Mercury, the time it takes to orbit the sun, is just 88 Earth days. That's right. In the time it takes us to go from winter to spring, Mercury has made a full trip around the sun. However, don't let this fool you into thinking that days are quick. Due to Mercury's eccentric orbit, a solar day, the length from one sunrise to the next, equals a whopping 176 Earth days. So, on Mercury, you could celebrate 2 birthdays before the sun sets. Now let's take a leap from Mercury's long days to the deadly exposure of space. Space, the final frontier, is a hostile environment for humans. If you were exposed to the vacuum of space without protection, you'd lose consciousness in about 10 seconds. Your blood would start to boil, and you'd swell up like a balloon due to the lack of atmospheric pressure. But hold on, it gets worse. Space is incredibly cold, so you'd also experience rapid cooling. The lack of oxygen would then do the final blow, causing death within 1 to 2 minutes. It's a grim picture indeed, so if you're planning a trip to space, better pack a good suit. Imagine a teaspoon so heavy that it weighs more than the entire human population. Welcome to the world of neutron stars. Neutron stars, these mind-boggling celestial objects, are the remnants of massive stars that have exploded in supernovae. They're incredibly dense, almost incomprehensibly so. Picture this, just a teaspoonful of a neutron star material would weigh over 1 trillion kilograms. That's right, 1 trillion kilograms. Heavier than all the humans on Earth combined. But the universe doesn't stop surprising us there. Meet the gamma-ray bursts, the biggest bang since the Big Bang itself. These are the most powerful explosions known in the universe. They're caused by the implosion of massive stars, or you guessed it, the merger of neutron stars. Imagine 2 of these super heavy teaspoonfuls colliding. The energy released in this cosmic event is so immense, it's equivalent to the energy our sun would release over its entire 10 billion year lifetime, but all in a matter of seconds. These gamma-ray bursts are not just spectacularly violent, they're also the universe's premier long-distance callers. They can be detected from halfway across the visible universe. When we pick up a signal from a gamma-ray burst, we're looking billions of years into the past, into an ancient era when the stars and galaxies were just beginning to form. So, the next time you're staring at a teaspoon, pondering the sugar going into your coffee, remember, somewhere out there in the vast cosmos, there's a teaspoon's worth of matter with a weight that's beyond comprehension. And if that teaspoon's worth of neutron star matter ever meets another just like it, Well, watch out for the fireworks. So if you thought your last kitchen mishap was a disaster, just remember, at least it wasn't a gamma ray burst. The universe isn't just sitting still, it's expanding, and it's doing so faster and faster. Now if you're scratching your head and thinking, wait, isn't everything in the universe just floating around? Well, you're not entirely wrong, but it's a bit more complex than that. Imagine the universe as a giant loaf of raisin bread dough. As it bakes, it expands, and the raisins, which represent galaxies, move farther and farther apart from each other. This is what's happening in our universe. But here's the kicker. This expansion is accelerating. It's like our cosmic loaf of bread is baking on turbo mode. This speedy expansion has a few implications. For one, it means that the first population of stars, the ones that ignited not long after the Big Bang, are now too far away to observe directly. They've essentially sped off beyond our cosmic horizon. It's a little bit like trying to watch a car that's speeding away from you. Eventually it just becomes a speck in the distance and then it disappears altogether. But let's shift gears for a moment and talk about something completely different, yet equally fascinating. White holes. If you've heard of black holes, those mysterious regions of spacetime where nothing, not even light, can escape, then white holes might sound like a science fiction invention. But they're not. White holes are theoretical objects that are essentially the opposite of black holes. Instead of gobbling up everything in their vicinity, white holes spit out light and matter. It's like they're taking everything a black hole would swallow, and instead, flinging it out into the universe. It's a mind-bending concept, but then again, so is much of the universe. So, remember, the universe isn't just vast, it's growing and it's full of surprises like white holes. Think your year's been long? Try being Neptune, where one orbit around the sun takes 165 years. Now that's what you call a long year. While we Earthlings whiz around the sun once every 365 days, Neptune, the blue giant at the far end of our solar system, takes a staggering 165 Earth years to complete just one orbit. Seriously, the last time Neptune completed an orbit, the light bulb hadn't even been invented yet. And speaking of orbits, let's talk about our friend Pluto. Since its discovery in 1930, this little ice dwarf has not yet completed one full orbit around the sun. That's right, folks. Even though it was demoted from planet status, Pluto is still out there, plugging along on its 248-year journey. But enough about long years. Let's switch gears to our very own solar powerhouse, the sun. This blazing ball of gas is continually losing weight, and we're not talking about a few pounds here and there. The sun is shedding around 1.3 trillion particles every second. That's equivalent to 1 billion kilograms of matter per second. Imagine losing a billion kilograms every second. That's like 200,000 elephants vanishing into thin air every tick of the clock. This constant shedding is a result of a process called solar wind, where particles are ejected from the sun's atmosphere and sent hurtling into space. In the grand scheme of things, though, the sun's weight loss doesn't make much of a dent. It's so massive that even after losing a billion kilograms every second for billions of years, it's only lost about 0.05% of its original mass. So, next time you're feeling a bit worn out, remember, at least you're not the sun, shedding a billion kilograms every second. Did you know that the speed of light isn't infinite? Yes, that's right. It's actually about 299,792 kilometers per second. To put that into perspective, light from the sun, which is about 149.6 million kilometers away, takes approximately 8 minutes and 20 seconds to reach the Earth. Imagine going on a vacation and your travel time is just under 8.5 minutes, no matter the distance. Now that's what you call light speed travel. But let's shift gears a bit and delve into something even more fascinating. The cosmic microwave background, or CMB. This is essentially the afterglow of the Big Bang, a remnant radiation that permeates the entire universe. It gives us a snapshot of the universe when it was just 380,000 years old. Now that's a real hash throwback Thursday. The CMB is a faint cosmic background radiation filling all space that is an important source of data on the early universe because it is the oldest electromagnetic radiation in the universe, dating to the epoch of recombination. With a traditional optical telescope, the space between stars and galaxies, the background, is completely dark. But with a radio telescope, there's a faint background glow, almost exactly the same in all directions, that is not associated with any star, galaxy, or other object. This glow is strongest in the microwave region of the radio spectrum, hence the name cosmic microwave background radiation. So, next time you switch on a light, remember, that light is traveling at an incredible speed, and it's part of a universe that's been glowing for billions of years. And who knows, maybe some of that light might even be a little piece of the cosmic microwave background, a tiny echo of the Big Bang itself. From the speed of light, let's now journey to our nearest galactic neighbor, the Andromeda galaxy. You might want to buckle up because Andromeda is on a collision course with the Milky Way. But hold on to your panic buttons. This intergalactic meetup isn't scheduled for another 4 billion years. That's right, we've got a bit of time on our hands. Andromeda, although a hefty 2.537 million light-years away, is moving towards us at a speed of approximately 110 kilometers per second due to the gravitational attraction between our two galaxies. Now, speaking of moving galaxies, let's talk about the Hubble constant. Named after the renowned astronomer Edwin Hubble, this constant is the current rate of expansion of the universe. Although it sounds straightforward, scientists have been scratching their heads for decades trying to pin down its exact value. It's a bit like trying to measure the speed of a snail that's constantly accelerating. Why all the fuss about the Hubble constant? Well, it's crucial for determining the age, size, and fate of the universe. So while we're waiting for Andromeda, we can keep pondering the mysteries of the universe's expansion. Remember, each time we turn our gaze to the stars, we're not just looking at objects in space, we're peering into the depths of cosmic time. So keep looking up, keep wondering, and keep exploring the fascinating mysteries of our universe. From the mysteries of the universe's expansion, let's travel back closer to home, to the outermost regions of our own solar system. Beyond the orbit of Neptune, there's a region of space filled with icy bodies. Welcome to the Kuiper belt and the Oort cloud. The Kuiper belt, named after the astronomer Gerard Kuiper, is a region of our solar system beyond the orbit of Neptune. It's filled with dwarf planets, such as Pluto, and a multitude of comets. Think of it as the solar system's cold storage unit. Even further out, there's the Oort cloud. The Oort cloud is a theoretical cloud of predominantly icy planetesimals believed to surround the Sun to as far as somewhere between 50,000 and 200,000 astronomical units. That's a mind-boggling 1.58 light-years away. Both the Kuiper belt and the Oort cloud are considered the birthplaces of comets. These icy visitors get flung into the inner solar system by gravitational interactions, providing us with some of the most spectacular celestial displays. So next time you see a comet streaking across the sky, remember, it's a visitor from the distant reaches of our solar system, carrying secrets of our cosmic neighborhood's cold outer edges. The universe is full of such fascinating places, each one a testament to the incredible diversity and beauty of the cosmos. Keep watching, keep wondering, and keep exploring. From the icy outskirts of our solar system, let's journey back inward, towards our very own star, the Sun. It doesn't just give us light and heat. The Sun emits a continuous outflow of charged particles, a phenomenon we call the solar wind. These are not just any particles, these are electrons, protons, and alpha particles with energies typically between 1.5 and 10 keV. They race away from the Sun at speeds as high as 900 kilometers per s. But where do these particles go? They form the Heliosphere, an enormous bubble in the interstellar medium that surrounds our solar system. This bubble isn't just for show, it serves a crucial purpose. It acts as a protective shield safeguarding the planets from the full impact of cosmic rays. These high-energy particles from distant galaxies could wreak havoc on life as we know it, but thanks to our Sun and the Heliosphere, we're kept relatively safe. The universe is indeed a place of unimaginable vastness and mystery, but it's also a place of intricate balance and protection. So, next time you're basking in the warmth of a sunny day, remember, the Sun is not just a source of light and life. It's also our guardian shield against the relentless cosmic rays from the distant universe. Stay curious, stay awed, and as always, keep exploring. Let's continue our cosmic journey and head back home to our very own galaxy, the Milky Way. This isn't just any galaxy, it's a barred spiral galaxy with a diameter spanning between 150,000 and 200,000 light-years. It's so vast that even light would take 100,000 years to traverse from one end to the other. But the Milky Way is not alone. It's just one of over 54 galaxies in our local cosmic neighborhood, known as the Local Group. Alongside our galaxy, the Local Group hosts other celestial giants like the Andromeda Galaxy and the Triangulum Galaxy. And yet, even our Local Group is but a small part of a larger structure, the Virgo supercluster. And if that wasn't grand enough, the Virgo supercluster is a mere component of an even grander entity, the Laniakea supercluster. So as we gaze up at the night sky, let's remember, we're just a small part of a vast cosmic neighborhood. It's a humbling reminder of our place in the universe, a testament to the grandeur of the cosmos. So, keep looking up, keep wondering, and as always, keep exploring.